All right, well, I trust you did well on your test. Students in here did fantastic. Very, very pleased. We did have one perfect test, so good job to Luciana on that. But many, many A's, many students very close to perfect on the test, so very pleased with how you did on Chapter 7. We progress into Chapter 8. We're going to get into what you read in your homework reading. But first, let's take a look at the written part of the homework, which had nothing to do with the homework reading, and that was page 301 at the top of the page, 34 to 44. So have your textbooks out. Open to page 301. Have your textbooks out, open to page 301, and some percent review. Again, this is stuff you're going to deal with on an everyday basis. You saw how much percent factored into money when we went through the financial literacy supplement. So lots of percents. Number 34 asked, what is 38% of 260, and what did you have, Kirsten?
98.8.
Good, with the two decimal places in there, 98.8. So not 9,880, but 98.8 is our answer. Number 35, we needed to find 40 is what percent of 64. And how do we find what percent something is of some other number? What do we have to do to find a percent? Jalen?
Divide 64 by, no.
Other way around.
40 by 64.
Could you make a fraction? 40 64ths, right? Now, I wouldn't actually divide it this way. I'd reduce it down first. What can we divide out of both 40 and 64?
4.
We can divide a 4 out to get
10 16.
10 16. We can reduce it even further.
5 to 8.
5 eighths. And wait, we memorized 5 eighths as a decimal class.
0.625.
0.625. And so if we make it a percent back to Jalen, we get
62.5.
62.5 or 62.5%. Very good. Number 36, we'll do the same kind of thing. What fraction will we make on 36, Luciana?
114 over 24.
That's number 38. How about 36? What fraction will we make?
54 over 360.
54 over 360. I at least see a 6 rather, that could be divided out of both of these. If we divide the top by 6,
9.
and if we divide the bottom by 6.
40. Wait. 60.
60. And then I can see a 3 that comes out.
3 over 20.
And we're trying to make a percent, right? And percent means,
Decimal.
well, it comes from a decimal, but percent means hundreds. I could now make this a 100 in the bottom if I wanted to.
15.
So what's my percent?
15%.
Now, you didn't have to do it this way. You could have just said 54 divided by 360. You could have done it that way. Still would have gotten 15%. But there's a way to do it without having to do division because we're lazy. Number 37, 72 is 12% of what number? How do we set this one up, Bryson?
Oh, you said which number? I was wrong.
Well, number 37, it says 72 is 12% of what number? How do we find the base?
Or you do 12 divided by 72.
The other way around.
Oh, 72 divided by 12.
Good. In any case, we take the first number, we end up dividing it by the second number, but it's not actually a 12, Bryson, it's 12%, so 0.12. Can I really divide by a decimal class? No, so I gotta go 1. But if I do it in the bottom, do it in the top as well. Now, Bryson, the nice thing is we know what 72 divided by 12 is.
8. No.
Careful. 6. But I still have these 2 zeros. What happens to them?
You just add 1.
Tack them on. So my answer is
600.
600. How many had 600 as the base on 37? And number 38, it said 114 is 24% of what number? Again, Joel, how do we set this up?
We multiply.
Oh, not multiply.
You divide 24 from 114.
Okay, from 114. The 114 divided by, but not 24, it's a percent, so make it a decimal. 0.24. And then again, can't divide by a decimal, so we gotta go 1. And if we boink top and bottom, it ends up giving me a 11,400 divided by 24. I could reduce a little bit here, Joel. I could divide top and bottom by...
6.
Actually, yes, you could divide by 6. I did not see 6. I saw 4 because I saw, the double zero. But you can divide by 6, actually. So we divide the bottom by 6. That's the easy part. Let's do that first.
4.
Or divide by 6, we get 4. And then dividing this by 6 is going to be a little bit more of a challenge. 6 goes into 11 with 5 left. 6 goes into 54. 9 with nothing left. And then it goes into the zeros, of course. Zeros. Well, this is going to divide evenly by 4 now. 4 goes into 19.
4
4 times with
with 3 left over.
4 goes into 30.
7
7 with,
2
and 4 goes into 20.
5.
That's one way to do it. Again, now, could you just say, no, I'm just going to divide by 24 and do it that way? Yeah, absolutely. We decided to reduce it down and then made the division, maybe made it 2 separate divisions, but they were a little more manageable, I guess. It doesn't really matter how you did the division itself. You got the 475. How many had that answer on number 38? Number 39, 6 hours. How many days, Michael? 1/4 of a day. Very good. 300 years. How many centuries, Kirsten?
3
3. 45 feet. How many inches, Jalen?
540
540. 31 feet. How many yards, Luciana?
10.1
Well, not 10.1. 10 with a remainder of 1.
10 or 10 1/3.
10 and 1/3, right? Because the remainder of 1 goes over the 3 we were dividing by. 10 and 1/3 yards. Let me go back to Luciana for redemption on 43. 204 inches. How many yards?
68
You divided by 3. And that gave you feet.
Oh,
Excuse me, that gave you something else. Because it was inches. We need to divide by 36. Let's go to Joel. 204 inches. How many yards?
4 inches is 5 and 2/3.
5 and 2/3 yards when we divide by 36. All right, third tries the charm, Luciana. 12 tablespoons. How many teaspoons?
4
Which is bigger, tablespoon or teaspoon?
tablespoons.
Right, think of serving the potatoes on the table versus stirring your tea. So the tablespoon's bigger, so we're going from larger to smaller. Multiply. Was this the only? No, for 41 we had to multiply. I said most of these were division. This one's a multiply by 3, so we should have had
48. Wait, no. 36.
36. 36 teaspoons should have been our answer. Questions on the homework. Some good review for us there. Any questions on that homework? Anyone perfect on the homework? A few of you, good. Anyone just missed 1 or 2? All right, questions on the ones we missed. All right, let's flip back in your textbooks, if you would please, back to page 296, where you began your homework reading. And we're beginning a chapter all about graphs. Beginning a chapter all about graphs. Most of these things you would have learned in your elementary years, 4th, 5th, 6th grade. So shouldn't be too much new stuff here. Want to talk about some different graphs, but if you would, just write this in the side margin of page 296. You need to know that a graph is a pictorial representation of data. A graph is simply a pictorial, sound it out, P-I-C-T-O-R-I-A-L, pictorial, representation, sound it out, of data. Big words, it basically means you're making a picture. You know why? Because people don't want to look at a whole bunch of numbers. They'd rather look at a picture. And a graph is a picture that represents data. It's a pictorial representation of data. Bless you. They say a picture's worth 1,000 words. A picture's worth 1,000 numbers, that's for sure, right? I don't want to look at a whole bunch of numbers. Show me a graph that tells me essentially what those numbers are saying. And so that's what the purpose of a graph is. We're going to look at several different types of graphs in this chapter. You see at the very top of the page, it has a little outline of the chapter. It lists the different types of graphs we're going to look at. Next to bar graph, at the very top of the page, would you jot this down? They compare related. So right up here at the very top of the page, right next to where it says bar graphs, just write this down. Used to compare related but independent data. They compare related but independent data. Compare related but independent data. You want to quickly compare things together that are pretty much independent, then that's how we would do it with a bar graph. Pretty straightforward. Circle graph, write this down. Used to compare parts to the whole. Circle graph is used to compare parts to the whole. Compare parts to the whole. You can cross out box and whisker plots. For sake of time, again, we have to cut stuff out because we added in the financial literacy supplement. So we're going to go into box and whisker plots next year in 8th grade as if you've never learned them before. 7th graders in years past had not learned them. So I teach it as a new concept in 8th grade. You're going to be fine next year. You don't need to learn that this year, though you're welcome to look it over if you want to. You can cross that out. Stem and leaf plots, also something that next year as an 8th grader you will learn as if it's a new concept. Because again, historically our 7th graders had learned it. I'm going to cut that out as well for sake of time. So you can cross those two out. You're welcome to look them over if you want to, but you don't have to know them this year in 7th grade. Histograms, write this down, show frequency within groups. Frequency within groups. We group things together and show how frequently different groups of data are accomplished. So frequency within groups. For instance, if we wanted to look at your grades on the last test, well, rather than showing like all the people who made hundreds, Luciana, and then all the people who made 99s and 90, well, why don't we just say all the people who made A's, then all the people that made B's, all the people who made C's, and we can just show how many people made A's. It's a group. It's like a bar graph, but it shows within a group of data as opposed to specific data values. And then line graphs show changes over time. Line graphs show changes over time. These show changes over time. By the way, as we get to each of these graphs, I'm going to reiterate it, but this just kind of gives you an overview as we go in. By the way, there are different types of line graphs. If you want to make a little note under line graphs, make a little note here under that place where it says line graphs. We're going to talk about broken line graphs, which is usually what we think of, where it's just line segments that do whatever they do. This is like stock market fluctuations or gas prices, where they just go up and down, that kind of thing. Curved line graphs. Curved line graphs. We may look at just a couple of those. They show continuous change. They show continuous change. And then I don't know that we'll see too many this year, but in algebra, you'll see what are called straight line graphs. In algebra, you'll see straight line graphs. These show a constant progression, where it's just a continual progression along a straight line. I don't believe we'll have those this year, but straight line graphs exist as well. With the bar graphs, if you look at the next page, if you flip over the page, you'll see an interesting looking bar graph, and you should have noted this as you were doing your homework reading. There's different portions, page 298, there's different portions to the bar graph, right? There's green and orangey, yellowy, and blue, and there's different colors, and that's called a stacked bar graph. A stacked bar graph shows percentages within groups. We can compare while showing groups. So stacked bar graphs, compare data, and show groups. This is all kind of an overview of what we're going to be covering here in chapter number 8 with graphs. But I want to focus first of all just on what I think is probably one of the easiest graphs, and that's the bar graph. Okay, the bar graph. By the way, some of you might be thinking back to your elementary days like, wait a second, you left one out, Mr. Nadaski. Which graph that you've probably talked about the past couple of years in elementary is not included in here?
Pictograph.
The pictograph. You know why? 2 reasons. One, I'm a terrible artist, so I don't like drawing pictures. Number 2, most people don't use pictographs anymore, but it's a fun one to introduce the idea of graphing to small children. But you are now progressed into the upper echelon of learners. You are no longer in the small children category. So anyway, say farewell, bid adieu to the pictograph, and many happy returns. Anyway, bar graphs. Let's talk a little bit about bar graphs. They use either vertical bars or horizontal bars. Obviously, if you look at the bar graph on page 296, so flip back again. Back to page 296, we see a horizontal bar graph. If you look across the page, we see a vertical bar graph. Okay? I personally prefer the horizontal bar graphs, but the book will use both of them. Couple of things we need to know about our bar graphs. First of all, every graph has to have a title. You see where it says chart title. Okay, chart title. Every graph has to have a title. Jot this off to the side. The title tells what the graph's about. The title tells what the graph's about. Title tells what the graph is about. You got to have a title. Ain't nobody want to look at a graph even on a STEM project display board. Nobody wants to look at a graph and wonder, what is this talking about? So the title is there so you know what it's talking about. Make sense? By the way, for those in my computer apps class, I know this sounds very redundant. You've learned this before. It's okay. That just means you have it easier than everybody else for right now. All right, the next thing you have to have labels or a legend. Labels or a legend. In this case, we have labels. On a bar graph, we use labels, typically. The labels tell what the bars mean, right? You see the labels on figure 1. Carpool, public transportation. Class, what are some of the other labels on here? Walk, other, worked at home. So either you carpooled, you used public transportation, you walked to work. Others, probably like you actually drove your own car, sounds weird. And then worked at home, so you didn't have to commute to work at all. Okay, so those are the different ways in which the people get where they're going. Those are the labels. Okay, you got to have labels on a graph or a legend. Now, this doesn't use a legend, but if you flip over to page 298, you will see a legend on here. You'll also see labels, by the way, on the graph at the top of page 298. The labels are the months of the year: Jan, Feb, Mar, April, May, June, July, Aug, Sept, Oct, Nov, Des. Okay, those are the labels. But you also see a legend. A legend is a color key. A legend is a color key that tells you what things mean. So circle graphs will generally have not labels, but a legend, where it says this color on the circle graph means this. Does that make sense? Okay, so the labels tell you what the bars mean. A legend tells you what colors mean. We got to have those things on there as well. Scale. If you'll write this down, the scale is the numbers on the bar graph. Okay, the scale is the numbers. Bar graphs and line graphs have to have a scale. We got to know what the labels, what the lines are, right? We got those little lines. Okay, what do they mean? This does us no good on your STEM project graph if you don't tell what the different lines along the thing mean, right? We got to know what this bar is tall, this bar is short. Okay, what does that mean? Well, this paper towel absorbed more than the other one, or whatever. Or absorbed faster than the other one, whatever. Right? So we got to know what the numbers mean. That's the scale. The scale are the numbers that tell you what the grid lines mean. Grid lines. Can you imagine trying to read this without lines on it? Just the numbers at the bottom? It'd be a little bit annoying, right? So grid lines are very helpful on line and bar graphs. We see those. By the way, notice we have dark black grid lines, and then we have thin black or gray grid lines. Do you see how we have skinny ones and fat ones? Okay? The skinny ones they don't have numbers on them. Do you notice that? They don't number those ones. Well, they don't need to. If they label the darker black ones 2,000, 4,000, 6,000, then we already know what the skinny little white, squinty little gray ones mean. Class, those must mean thousands, individual thousands, right? So like 1,000, 3,000, 5,000. We don't need to label everything because we are lazy. So we only label what are called the major grid lines. We only label what are called the major grid lines. That make sense? So the minor grid lines, we don't label those. Those are there for good reference. They help us to read the graph, but we don't actually got to label them. We label the major grid lines. Something else that you see there, the numbers, 0, 2,000, 4,000, 6,000. What are those numbers talking about, class? Total workers, right? That's called an axis title. Axis titles, if you'll jot this down, help the labels and scale to make sense. Right? What are those labels? Carpool, public transportation. Well, those are the different methods of transportation. What do those numbers mean? They're talking about how many workers do those sorts of things. So the axis titles help the labels and the scale to make sense. Now, some important things to note, and you'll have to write this off to the side. Bar graphs and line graphs should never reach the top or the end of a graph. Bar graphs and line graphs should not reach the top or the end of a graph. If it touches the top, it gives the illusion that perhaps you ran out of room. If there's space at the end, it shows, nope, this bar actually means what it looks like it means. So we never would, if we were making a bar graph, we would never let the bar hit the end of the graph. Or if it's a vertical bar graph, we would never hit the top of the graph. Does that make sense? And admittedly, we're not going to be making a whole lot of graphs here. We're basically going to be spending our time learning how to read and interpret the graphs and making sure we understand them. And of course, in computer class, the computer generates in such a way that it never hits the end of the graph anyway. But if you were to hand draw a graph, if you felt you had to do it that way because you couldn't figure out Excel for the STEM project, you wouldn't want the bar to hit the top or the end of the graph. Somebody feels targeted right now. I don't know anything. I haven't heard anything about it. I'm just saying. Also, bar graphs should start at 0. Bar graphs should start at 0, unless there's a really good reason to make some other change. Bar graphs should start at 0. So we say, yeah, but my smallest number is like 3,500. Why don't we just start there? Because it makes a hard comparison. So we want to make sure we start at 0 so that our graph doesn't appear to lie. Okay, so bar graphs should start at 0. Let's look at this bar graph here on page 296. At a glance, I don't have to look at a ton of numbers. I can tell at a glance what most people in Salt Lake City do to get to work. Class?
Carpool.
Most people are carpooling, right? Most people are like, hey, you're driving? I'm going to the same place. Can I ride with you? I'll wait over here. You pick me up. Second most common way people get to work in Salt Lake City. Public transportation, that's buses, light rail, trolley, whatever, right? That they're riding what the city provides. You pay a little bit of money, they take you where you want to go to the next stop. About how many people walk? A little over 5,000, right? Maybe 5,200-ish, something like that, but a little over 5,000 people walk. About how many people work from home? Just a touch under 4,000, maybe 3,800-ish people work from home there in Salt Lake City. That excludes solo drivers. See, that's good to know from the title, because I was like, what about people actually just drive? That's excluded here. So that title helps us to know, the other isn't talking about people who just drive themselves. I wonder what the other is then. You're not walking. Bike. There we go, bicycle. Ride a bike or ride a Segway. That's awesome. All right, what'd you say?
Skateboarding.
Skateboarding to work. There we go. What a way to show up. Roller skate. Anyway. But anyway, makes sense how to read the graph. And again, it's an easy way instead of having to look at boring numbers, because nobody wants to look at boring numbers. They'd rather look at a graph. Look at the next graph on the top or on the next page. What's the title of the graph on page 297, Joel?
North Carolina cities, population 2010.
Okay, so that tells me we're talking about cities in what state class? North Carolina, and this was when? 2010. Okay, so this is old data, right? This is from 14 years ago. So are these numbers going to be the same? No, surely the numbers have changed. We presume the numbers have probably gone up. Probably. Now, there are some cities in America where the population has been dwindling because people want to leave. You hear about it in the news, San Francisco and New York City, high crime, high homeless population. People you know what, I didn't sign up for this. I'm going to move somewhere else. But mostly, no, nobody's actually there. All right, false alarm. But mostly cities are growing in population, so we presume the numbers are probably higher. Just at a glance, what city, back in 2010 at least, presumably still does, is the most populous city in North Carolina? Corey?
Charlotte.
Charlotte. Now, those of you who know your states and capitals, what's the capital of North Carolina?
Raleigh.
Raleigh. So Charlotte is the most populous, but it's not the capital city. Any idea why?
The Hornets.
Because of the Hornets. Of course, everybody loves the Hornets. Anyway, realize when they pick capital cities, they try to pick something that was centrally located in the state, so that way people could get to the state capital more easily. Charlotte's not necessarily in the center of the state, but Charlotte does have the Hornets. It also has a major airport for United. Trying to remember, not United Kingdom. There's one of the major airlines has a big hub there in Charlotte. But anyway, Charlotte's the biggest city. What are the labels on this graph, Elaine?
Population by 1,000.
No, that's not a label. What are the labels? Jalen?
Charlotte,
Raleigh.
Greensboro, Winston, Salem, Durham, and Wilmington.
There we go. So the labels are the words that tell you what each bar individually means. Those are your labels. Now, Elaine, the 0, 100, 200, 300, 400, those are our, not the labels, but we call that the...
Category? No. The axis. Scale.
The scale, there we go. Okay, so everybody see it? The numbers are the scale. The words that tell you what each bar means, those are the labels. Do we see the difference? Scale is numbers, labels are words. Now, there are not a little over 700 people in Charlotte. Right? That's not 700, class. That's 700,000. But you know what? Mathematicians are lazy. We don't want to write 0, 100,000, 200,000, 300,000, 400,000. That's a whole lot of extra zeros, right? It's faster to use population by thousands. What do we call that thing off to the side that tells us that this is actually meaning population in terms of thousands? Luciana? It's one of our axis titles. Does that make sense? Now, I think we would actually be fine without the bottom axis title, class, which says cities. Seriously, we kind of know those are cities, since it said North Carolina cities population. So I don't know that we needed the lower axis title, but it certainly doesn't hurt anything to have it. What are the dark gray lines that are actually labeled for the 800,000, 700,000, 600,000? We call those what, Kirsten?
Minor lines?
The ones with the numbers next to them, the dark ones.
Major.
Those are the major grid lines. There we go. And then we've got the little bit skinnier lines. They don't have numbers. Those are called, Bryson, the minor grid lines. How big or how much do each of the minor grid lines represent? Well, how many minor grid line spaces are there, class, between majors? 4, right? There's 3 lines but 4 spaces, right? So if there's 4 spaces, and what's the difference between the major grid lines? 600, 700, 800, what's the difference between them? 100. So if it's divided into 4 parts, that means each minor grid line must mean 25,000, right? The 1,000 is kind of assumed off to the side. Does that make sense? If we've got major grid lines that say 500 and then the major grid line says 400, and then we've got these 3 lines in between, 4 spaces, each space must be another 25 to get you here, right? So this would be 425, 450, 475, and then 500. Does that make sense? So we have to know what the minor grid lines mean to get the reading here, which means Charlotte back in 2010 had approximately a population of 725,000 people. What about Raleigh? Well, that one goes right to the major grid line, class, so Raleigh would have had about 400,000. Greensboro almost gets to what line, Michael?
275,000.
Almost 275,000. So maybe it's like 265, 270,000. It's really close to 275,000. What about Winston-Salem? What does Winston-Salem almost get to, Jalen? Almost 225,000. Do you notice Durham has about the same population? So if there were a question asked, which 2 cities have about the same population? Well, obviously we see from just looking at it, Winston-Salem and Durham's bars are the same, right? Now, of the 6 major cities, which has the lowest population, class, or had? Wilmington. We presume it probably still does. It's just a touch over 100,000 people. Anyone know about how many people are in the city of Columbus?
200,000.
Between 200 and 250,000. So we're about the same size as Winston-Salem or Durham. Okay, not quite as big as Greensboro, but getting close to that. Okay, questions on those different bar graphs? Makes sense how to read it? Do we understand the different parts? Again, at the top of the graph, it tells us what it's about. Class, that's the title. Then we, of course, have the bars either going up or going sideways. If the bars are going sideways, we have a little word next to each bar telling us what it means. If we have bars going up, we have words at the bottom telling us what each bar means. The words that tell us what the bars mean are called the labels. Then we've got numbers that either go up for vertical or across. The numbers are our scale. And we number the dark lines, which are called the major grid lines. We might have thinner, lighter lines in between that called the that help us to read more detail on the graph. And then the things that tell us what the labels are talking about or what the scale is talking about, those things that might be there or might not be are called axis titles. They're very good. Several things we need to know. Turn the page. Let's look at some different, a little graph here at the bottom of page 298. And what is the title of this graph? Ben? They're at the bottom of 298. What's the title of that graph?
Heights of selected U.S. buildings.
Good. Heights of selected U.S. buildings. By the way, do you see why it would be good to have vertical bars when we're talking about height? Kind of like in your STEM project, because you're talking about how high water rises in capillarity, you're going to use vertical bars. It would be weird to use horizontal bars. Even though that's my preference, if it's logical to use vertical, we of course want to do that. What are the 5 buildings that are being compared in this particular graph? Corey?
One World Trade Center, Willis Tower, Bank of America Tower, J.P. Morgan Chase Tower, and Aon Center.
Very good. And the things he just read, class, are the labels. Those are the labels. All right. How far apart are the major grid lines?
200.
How far apart are the major grid lines, Elaine?
200
200 what?
feet.
Feet. How do we know it's feet? Because of the
Axis.
axis title that tells us we're talking about feet. Okay, which means how high, what do the minor grid lines represent? If the major grid lines represent another 200 feet, the minor grid lines must represent what, Griffin?
100.
An extra 100 feet because there's only one grid line in between to break it up. So approximately how tall, well actually let's just go through the questions now that we've analyzed it a little bit here. Which building is the tallest? We can tell just at a glance. Kirsten?
One World Trade Center.
Good, you can write OWTC if you want to. One World Trade Center. That's the building that was built in place of one of the Twin Towers that was knocked down. Remember the other Twin Tower where it was, there's now a large reflecting pool that's there as a memorial to those who died. Which of these buildings is the shortest building? Jalen? It's not the shortest building in America, certainly, but of the 5 they selected, the shortest is obviously the Aon Center in Los Angeles. Good, Aon Center. All right, here's a fun one. Which building is about 1,450 feet tall? Which building is about 1,450? Bryson? The Willis Tower in Chicago. It used to be called the Sears Tower, if you've ever heard reference to the Sears Tower. That's the same building, they just renamed it. But the Willis Tower is about 1,450 feet tall. It's the only one that's a touch over 1,400. Which of these buildings is in Los Angeles? Which of the buildings they chose is in Los Angeles? Michael?
Aon Center.
The Aon Center, good. We asked this already, number 5, but what's the value of each major grid line class? 200 feet. Write that down, 200 feet. And the value of each minor grid line, of course, we already said class is 100 feet. Number 7, are the bars vertical or horizontal, Joel?
Horizontal.
Oh,
I mean, like.
vertical. Vertical's this way. There we go. Oh yeah, vertical goes up and down, horizontal goes side to side. So vertical bars used here. Good to know the difference between those two. By the way, you'd be surprised, even with seniors occasionally in class, I use the term vertical and say, wait a second, vertical. That's this way, right? So yeah, verticals, you're going to have to know this the rest of your lives. Vertical goes this way, horizontal goes this way. Number 8, can this graph be used to obtain an exact or an approximate height of each building? Looking at the graph, do we know exactly how tall the buildings are? Do we know approximately how tall these buildings are? Corey, what do you think? Yeah, this is going to be an approximation because the best detail we can show is to 100 feet, right? Well, I mean, what if the building is, like, what if the Willis Tower is 1,449 feet? Are you going to be able to show that on this graph very well? No. So it's good for getting approximate heights. How tall is the One World Trade Center approximately? What do you think, Ben? About how tall is One World Trade Center? Looking at the chart, looking at the graph, don't try to guess, you're not trying to guess. Well, look, which bar, 1st through 5th, is One World Trade Center?
Like.
The first bar, right?
Yeah.
Okay, now it almost goes up to what line?
1,800.
Almost 1,000, but not quite, right? So let's pick a number that's just a little smaller than 1,800.
1,799.
Possibly, though I think they would just let it touch the 1,800 at that point. Michael, what's your guess for the approximate height of One World Trade Center?
1,770.
Around 1,775 is what the book says, but even that's an approximation. Somewhere around the 1,770, 1,780. Probably not 1,799, because they probably just let it hit the 1,800 at that point, but it's a little under 1,800 feet. All right, look at the next page. We got some rivers in the world. Some rivers in the world, and they've got just their various lengths. They've omitted, of course, the longest one in the world class, which is the Nile River. They've not had that one on there, nor the world's largest river by volume. Anyone know what that one is? The Amazon is the largest by volume. Neither of those is on here, so these are not supposed to be record breakers. It's just randomly selected rivers. And which 5 rivers did they select for this graph? Ben?
The Po.
It's a panda. Just kidding.
That was a good one.
Keep going. Just give it your best shot, brother.
Zangwa.
Sure.
Paraguay.
Paraguay, yeah. Or that's how Americans pronounce it. I don't know how it's actually pronounced.
Mississippi.
We got that one. That's us. Okay, we know about that one.
Congo.
Congo. There we go. Okay. So, about how long, number 10, is the Paraguay River? About how long is the Paraguay River? Well, first thing we need to know is how far apart are the major grid lines, class?
500.
500
Kilometers.
kilometers. Okay. Now, based on the minor grid lines, how big is each minor grid line going to be?
100.
24.
Another 100, right? Because it's 500 between majors, right? 500 between majors, and there's 5 spaces. So each minor grid line is another 100. So look at the Paraguay River. About how long is that river going to be, Kirsten?
26.
Just a touch over 2,600 kilometers. Good. 2,600 is just a touch over. So I would guess maybe 2006, well, but again, if each bar is 100, it's nowhere close to the next bar. Let's just say about 2,600 kilometers. I like that. Which river is about 4,700 kilometers? Which river is about 4,700 kilometers, Jalen? The Congo River. It goes right to that 4,700 minor grid line. Ooh, here's a fun one. How much longer, approximately, is the Mississippi River than the Paraguay River? Well, first, how long is the Mississippi River approximately, Joel?
300, 600, 3,600.
Well, remember, each grid line is 100, but it goes to 2 grid lines beyond 3,500. So actually, Mississippi should be closer to 3,700 kilometers. So right there on the Mississippi bar, just right 3,700. And then what about the Paraguay River? We already said it's about how long earlier, class? 2,600. Okay, so if Mississippi's about 3,700 kilometers and the Paraguay River is about 2,600 kilometers, about how much longer is the Mississippi River then, Joel?
1,100.
About 1,100 kilometers. Again, we can tell this from a graph without having to look at hard numbers. We can get approximate numbers. Which rivers on the graph are shorter than 2,000 kilometers? Luciana?
Po and Songhua.
There we go. Po and Songhua is how I'm guessing it's pronounced. Songhua, but I don't know for sure. Of the rivers on here, about how long is the shortest river that they chose? About how long is the shortest river that they chose? Corey? Well, the shortest one is the Po. About how long is it, though?
Like 7.
Just a touch under 7. It's clearly under 700, so let's make a guess a little bit under 700. 670 kilometers sounds good to me. The book says 650, but I don't think so. 650 would have to look like it's halfway between the 600 and 700 minor grid lines. It doesn't look like it's halfway between in my book. It looks like it's a lot closer to the 7, so I'd say about 670. Sounds like a good guess to me. Look at the last chart on here. Possible cities for convention. Class, what I just read is the title. The 5 cities they've listed are the labels. And apparently there was a group that voted where to have the next convention, and the number of votes, those numbers, class, are our scale. Now we know that those numbers mean votes because of an axis title. We know that those numbers mean votes, but most people voted for what city, class? Atlanta. Go us. Well, almost us. We're about 2 hours away. The fewest people voted for New York because they don't want to get mugged. That's actually number 15. That's number 15. What city received the fewest votes? NYC, New York. Which cities received more than 50 votes? There's 3 of them. Which cities received more than 50 votes, Griffin?
San Francisco, St. Louis, and Atlanta.
There we go. St. Louis, it's a pretty good place, especially during baseball season. Baseball heaven. All right, anyway, we just don't win championships since 2011. How many votes did Houston receive? How many votes does it look like Houston received? Ooh. Well, how big are the minor grid lines, class?
10.
No, major grid lines are 10, so the minor grid lines are only...
5.
There's 5 of them, so 2. Right, you see how there's 5 spaces between the 10s? So each minor grid line has to be 2. And Houston is between the first and second minor grid line. So Houston had to have gotten how many votes, class? 33 votes. Do you see it's between the 32 and 34? Which city received the most votes? We already answered this, class.
Atlanta.
So where are they having the convention?
Atlanta.
They're having it in Atlanta. How many votes did St. Louis receive? And we'll get this from Bryson.
St. Louis received 71.
71, because it's in between 70, the major grid line, and the next minor grid line, which would be 72. Questions on these? Do we see how to read graphs? Bar graphs specifically. We'll talk more about these tomorrow. For homework this evening, pretty short assignment for a change. Page 301. the homework 1 to 13. Page 301, the homework 1 through 13. Page 301, numbers 1 through 13. Take a look at that tomorrow. Have a wonderful rest of your day. And when the bell rings, you will be dismissed.